Hi, Abby. It's Miss Kosh. I want to talk through this worksheet. I'm not going to do all of it for you, but I want to talk through a few things. First of all, when I have this a times b to the x, it's a growth function when b is bigger than 1. So whenever b is greater than 1, if it's just 1, then you've just got a times b, and it's just a nice horizontal line. But once it gets bigger than that, then it starts growing. When is it a decay function? When b is between 0 and 1. We're not going to look at negative b values. So what does a represent? Well, if I plug in, if I have f of 0, I get a times b to the 0. Well, anything to the 0 power is 1. And so then I end up getting that f of 0 is equal to a times 1 is just a. So what does a represent? It represents the initial amount. Okay, what does b represent? It's either the growth or the decay factor. Okay, one thing that they'll make a note of, or they'll say is, if something, let me come down here. They'll say if it doubles, then we would say something, we'd have y is equal to a times 2 to the x, and then that would be that its growth factor is twice what it had been before. If it says it grows by 15%, then what we have is we still have 100% of what we had before, but we add an additional 15%. So this becomes 1.15 as our b value. If they had said it decays by 15%, then we would do the same idea except subtract. And so then our b value would be 0.85. Okay, coming back here, when we want to do, so I wrote this worksheet with the Casio in mind, and I'm not going to do this problem, but I did want to show you, oh, you know what, I should have, well, okay, I Googled I Googled exponential regression in Desmos. And so what they show me here is, what they've done is they've gotten your x1, they've got these years, and they've got a y1 and a y2. So they've got two different equations going on. I think if we zoom in more, would we see what's happening? Well, maybe not. I don't know. They're taking this, oh no, it's going to be way out there. We're going to have to zoom out because we've got an x value of, there we go. Okay, I thought I might, whoa, oh my goodness, I don't even know what we're looking at. What they've done is they've taken their x values and their y values, and then they came down here and they did this y1 is, and they have that little squiggle to have you do a regression. So basically the idea is that if we plot these points, and we have, I don't know, we've got something like this. The calculator or Desmos will come through and show you what curve it would fit that data. I think I have a video for how to do it on the Casio. I will go look. But this is definitely helpful. This was what I needed. I needed the reminder on how to do it with Desmos. So if all else fails, Google. And so then they do, so if they wanted to do, so notice their exponential regressions are in the form a times b to the x, and so then they can change those different ones because they've got three sets of y values, I think is what am I doing? What they're looking at. So they have three equations, and then they decided, well, let's go ahead and find a line that fits that. Oh, and then they did quadratic. So they did a bunch of different things. I found that on Google. So that's how you're going to want to do that. Next thing. So notice this is years past 2000. So what can you expect in the year 2016? Basically what's happening is you came up with an equation and your data fell in this range roughly, and then they're asking you find something out here. Well, we have no idea how valid that is because we don't know that the trends are going to continue in that same direction. So it could be that COVID happens, and that will be funny in the future, I guess. But things may have changed, and something big and drastic may make it so that it no longer follows. That is an extrapolation. Okay, that's what happens when you have to try and find an estimate for your value outside of your data set. You have no idea what could change the trend. In the year 2007, for the next part, that's going to be somewhere within your data set. That's an interpolation. And that one you feel more confident about because you know what came after that. So you may not be exactly right, but the point that you would get on that curve in the year 2007 is probably very close to what actually happened in 2007. And so that's the difference between extrapolation and interpolation. All right, good luck. Hopefully that helps you get started on your practice IA.